Hello, my name is Boris Howard Edwards, and today I will be talking about Newton's second law. Newton's second law states that F equals ma, which means force equals mass times acceleration. This law can be used in a lot of different ways. You can use it to determine that a bigger hammer will do more damage than a smaller hammer, because in a bigger hammer there is a greater mass and the same acceleration, so it will do more damage to whatever you're hitting. I'm going to be demonstrating this today by dropping a massive hammer and a small hammer onto some rotten food. And we will see that the small hammer makes a small imprint and the bigger hammer makes a large imprint. First, before we can demonstrate this law though, we need to know that the hammers fall at the same rate. To do this, I will drop both the hammers off the balcony and they should hit the ground at the same time, or if they don't, it will be because I dropped them wrong. Right, now for the bit you've probably all been waiting for. I'm going to drop some hammers on some rotten food and fruit and all that kind of stuff, and it's going to be really messy and look really cool in slow-mo. The best thing about it is I'm gonna do it so you don't have to make a mess of your house. But while we are doing something that's quite fun, there is still science behind it. The larger hammer, as you will see, will create a much more devastating effect to the rotten fruit. I'm not going to be dropping them from that high because two hammers, both of them would do quite a lot of damage to some rotten fruit if you drop them off a skyscraper. So I'm going to be dropping them from about 50 centimeters onto the fruit. But it's important that when I drop them, instead of just letting go like that, I need to make sure my hand is steady at the same height so that my hand doesn't move when I let go. Because, as you saw in the first experiment where I dropped the two hammers, I pulled one of the hammers up a bit so they fell at different times. If I was doing this with the experiment of dropping stuff onto food, it would skew the results slightly. Anyway, enough chit chat, let's get on with it. Right, so we saw that the first ones from 20 centimeters, the big hammer, which is really heavy, I think it's 12 pounds, destroyed the tomato, which was not surprising at all. But what was surprising was the fact that the small hammer on the first take actually bounced off the tomato, leaving no imprint. Now, we know that the bigger hammer was gonna destroy the tomato more because it had a greater mass, and the deceleration, which can be thought of as acceleration in the formula force equals mass times acceleration, is the same because they both go from the speed they were traveling when they from 20 centimeters to 0. The only difference there was the mass, and we saw that the mass of the larger hammer was in fact greater, so it caused greater damage. An interesting thing, however, was that when we dropped the smaller hammer from 40 centimeters, the velocity of the hammer was greatly increased as it from the 40 centimeter drop. But the interesting thing about that was when it decelerates much faster, which means it has greater acceleration, which means the force required to cause that is greater. So instead of bouncing, that also obliterated the tomato, much like we saw with the bigger hammer. So we actually saw that the acceleration changes relative to the change. When the acceleration changes, it does much the same thing as when the mass changes, which makes sense if the formula is force equals mass times acceleration, because if you times anything by anything, if you double one of them, it will be the same as doubling the other, because multiplication doesn't matter what order you do it in. So as we saw, the first one was a heavier hammer, which means that that was m times however much more the hammer weighed times acceleration. But then we saw that the second one equals however much a small hammer weighed times acceleration times whatever the increase in velocity was, which meant that the deceleration was faster. Thank you.